And welcome, viewers, to the Daily Space Weather. We look at the sun in a whole bunch of different spectra. And we're starting out doing just that. This is 94 angstroms. One of the ultraviolet wavelengths of ionized iron that the Solar Dynamics Observatory looks at. This one takes 10 images per minute, by the way, instead of only 2. 94 angstroms specifically formulated to study coronal mass ejections, solar flares, etc. Here's 335 angstroms. This is actually iron 16, 15 times ionized iron. The cool blue tones, also good at showing things like solar flaring. You can see all those bright spots. 4 of them, only 3 of them, are currently sunspots. This one up here is just a plage. These 3 are indeed sunspots. They're all small alpha-class sunspot groups. And if you want to look more about the wavelengths, head to the SDO page. You can go to the Sun Now page. And for example, that was 335 angstroms. There you go. That is highlighting the active region of the outer atmosphere of the sun known as the corona. 15 times iron, 15 times ionized iron for iron 16. About 5 million degrees Fahrenheit for that. Here's your colorized magnetogram. All 3 sunspot groups have remained rather stable over the past 24 hours. Likelihood of major flares not really there. We'll talk about some likelihood of some coronal mass ejections. Not really on the earthly side of the sun at the moment. The radio flux still quite low. It's the most proportional data set we have to solar activity. You can see right around 80 here. I think it's at 79. Let's get to the Space Weather Enthusiast dashboard and take a look. 79 solar flux units indeed. And we did see some geomagnetic unrest showing up a little bit earlier than perhaps Noaa expected last night. We'll get to that in a minute. First, let's talk about earthquake droughts. We're currently seeing one. Here's 2010. And you can see the space between those red bars. That would be an earthquake drought. 2010 was pretty active. 2011 a little bit less so. There was a large drought between May and August in 2020. I'm sorry, that was 2012. Big drought in 2012 there. There's 2013, 2014, 2015, and so on. And here's the past 90 days. You can see we are currently in an earthquake drought. A little bit of an uptick here. No big quakes over the past 24. Let's scroll up the list. There was a 5.2 in Iran, perhaps an aftershock of that, I think, 6.3 magnitude that struck the Islamic Republic. Deep quake in Indonesia. It was a 4.8 magnitude over 150 kilometers. Some deep quakes at least one deep quake in Argentina. Similar in size and depth to the Indonesian quake we just covered. Fiji Islands area saw an over 560 kilometer estimated depth quake there. That was a 4.4 magnitude. If that happened at the surface, that would be like a 6 magnitude quake. South Sandwich Islands still experiencing earthquakes. They're a 5.0 at the South Sandwich Islands. The most seismically active region on the planet over the past month or so. There's one in the southern Indian Ocean, pretty much right in the middle of the Indian Ocean. And let's look at volcanoes. We see an uptick happening here at volcanoes. And the 5 magnitude volcano that we covered in Iceland, actually a 5.2, was under Vatnafjall volcano. Yes. Anyway, now Hekla on the list. Don't be a Hekla. Press like and subscribe. Leave us a comment. Tell your friends about our channel. Thanks and congratulations for tuning in. Anyway, Hekla often does not show any signs of eruption, and so now it's on the list. It could be about to begin erupting, and it's pretty dangerous volcano as well, folks. La Palma also erupting here explosively. Still producing a similarly sized plume of volcanic ash there. It's an 8,000-foot ash plume. And here's a little bit of a volcano area tornado going on. The heck? All right, here we go. Little minor tornado happening there around the lower slopes of the La Palma volcano. Can we go full screen? Full screen not supported. Anyway, continuing on, Subanose Jima, also erupting, flight level 060, Mount Ibu exploding. That's located in Indonesia. That's a 7,000-foot ash plume from Ibu Semeru. Flight level 140, decent sized, nearly 3-mile high ash plume there over East Java. Samisa Pochnoi exploding. Occasional low level of eruptions have produced a 10,000-foot plume of volcanic ash. Fuego, 15,000-foot ash plume as Fuego explodes. That's in Guatemala. Nevado del Ruiz, 19,000-foot ash plume from Nevado del Ruiz as it explodes. Sangay exploding in Ecuador, producing a 19,000-foot ash plume over that country. Revenador, also an Ecuadorian volcano, also exploding, 15,000-foot ash plume. Intermittent emissions from Sabancaya in Peru are a reminder not to pole vault the caldera. And this is a reminder from me to visit our links. Visit the links below the video if you like these videos and you'd like to see them continue to exist, be publicly visible and free for all to view. Support our channel. They make great gifts. So do not pole vault the caldera. To quote Winston Churchill, if you're going through hell, keep going. Today's featured product is the My Vaccination Status is None of Your Business products. It is our best seller. And while I'm wearing a Mensa hat, which stands for Make Earth Not Suck Again, here's the featured product. It's the classic tee in orange, because nothing says don't run me over or shoot me like a blaze orange piece of clothing. Your vaccination status is none of my business. Universum Liberate. Visit our links. Visit smashamash.com. You can find the links there. The SMASho merch link is the one we were just on. They were sorted in order of best selling. Also, consider joining the Smash team if you want all kinds of information nobody else gets to see on our YouTube videos. This video was exclusive to YouTube. We're also on BitChute, Twitter. We're all over social media. And some of those social media agencies don't even attempt to censor us, like pathetic Meta, otherwise known as Facebook. Let's break down a bunch of magnetic data now. Since stars could be described in many ways, one of them would be via their magnetic fields. Here are the GOES 16 and GOES 17 magnetometers measurements. They are in a geosynchronous orbit around the Earth's equatorial region, and the reason that we show these M's and N's up here, these M's and N's, those are midnight and noon time, local time for the satellite. Those arc-jet moments are when the satellite operates its thrusters to make sure it retains its altitude and location over the equatorial region of the planet, and so on. Next, we use polarized light to determine the polarity of the plasma in the heliospheric current sheet. And that enables us to model things like this. It's the top view ecliptic plane field plot. It's part of the National Sunspot Observatory. It's one of the most important things that we use to forecast solar activity. This would be very low on the list if I had to eliminate sources of data. Earth is in a South Pole current sheet shown in red. Here's a line of sight view of the same stuff. Basically, it also shows you the solar magnetogram since we're viewing from the line of sight perspective. Here's the line of sight coronal hole plot. And some of those South Pole oriented coronal holes are what provided the geomagnetic unrest last night. That has since subsided, by the way. More South Pole oriented coronal holes rotating in, as you can see here in the 193 angstroms imagery. And those are non-transequatorial coronal holes. As the solar cycle progression continues at a very slow pace, Next, our flare monitor and detected sunspot groups, 2894, 2896, and 2897 are not significant sunspots. They're all alpha class. They only have one polarity umbra. Let's move on. There are some filaments on the Earth-facing side of the solar disk, and we're not calling a coronal mass ejection watch or anything like that, except for on the opposite side of the sun. We'll get to that in a minute. As far as solar flaring, not a lot of flaring. Again, those sunspots are not magnetically complex. No proton strikes, no relativistic particles, whatever you'd like to call them, have struck the geospace recently. No major flares. Let's take a look at the real-time solar wind. And the solar wind speed has subsided here a little bit, but it's a continuing high-speed solar wind regime. So the density made it all the way up to, it made all the way up to over 60 protons per cubic centimeter. There's a reading of 65 protons per cubic centimeter. Quite a high density spike there. And those South Pole-oriented coronal holes we just showed you are pretty well defined. Solar wind speed made it all the way up to over 600 kilometers per second. Current conditions are right around 600 kilometers per second. Density 6.3 protons per cubic centimeter. As the high-speed coronal hole wind stream continues. Phi angle, pretty consistent here over the past about 10 hours. BTBZ right around the zero line there. So not that strong of a field and not super strong South Pole orientation there. Not a big negative BZ component there. Continuing on, here's your KP index. Over the past 3 days, you can see a 12-hour period there of geomagnetic unrest as a result of that coronal hole wind stream. Next, your geospace magnetosphere movie over the past 4 hours, showing magnetohydrodynamic, let's try again, showing magnetohydrodynamic pressure, nanopascals. We've got fairly homogeneous wind over the past 4 hours. We don't see any major changes happening in the geospace magnetosphere movie. Lots of aurora photographs around the internet. Ground magnetic perturbations give a great indication of where you can see them. It looks like a bunch of aurora would have been visible in Canada just a few hours ago. And now that's subsiding a little bit there. Just in the past about 2 hours. Like the last video, this is 4 hours. Keep in mind this is magnetic flux density in nanotesla, not nanopascals, which is magnetohydrodynamic pressure. Follow me on Twitter if you don't. I probably won't ever get banned from there. I don't do idiotic things on Twitter. And check out the stunning imagery here. Multiple green curtains rolling in from Willard Sharp, storm chaser and photographer. Shout out to Willard. Well done. Drop us a line. Next, a forecast for the solar system. We've got Mercury moving into the LASCO C3 imagery. We'll show you that in a minute. If you're wondering where stuff is in the solar system, here's where it is now. And there's where it'll be in a week. Here's a star chart real quick. We've got Mercury rising ahead of the sun as well as Mars once again. I like to face mine to the south. That's in the-sky.org. And let's take a look at a couple of coronagraphs. One at stereo A, located at Lagrange point 5, which puts Earth off to your right. The other at the LASCO C3, located at Lagrange point 1. LASCO C3 on your right, stereo A on your left. I'll just put this out there. We've got a far side coronal mass ejection watch. Nothing on the Earth side at the moment. If that changes, we'll let you know. Especially the SMASH team. We'll find out long before anybody else. And you can see Mercury moving into the frame here in the LASCO C3. No coronal mass ejections showing up on the imagery at the moment. Let's do a brief cosmology segment. We're going to talk about the galactic core a little bit. Yeah, the galactic core is a very interesting place. And what's going on around the galactic core looks a little bit like that. Yeah, a bunch of supermassive blue, really hot stars are orbiting the galactic core at speeds that approach the speed of the solar wind, hundreds of kilometers per second. Yeah, those are stars orbiting a massive radio source known as Sagittarius A star. So the first thing we'll do in our cosmology segment today is look at the astronomy picture of the day. It's some time-lapse overlay imagery here, it looks like, of a meteor shower. apod.nasa.gov is where you can find it. There's the constellation of Orion, and there's Gemini, indicating that these are Geminids, as they're emanating from the constellation of Gemini. So those would be Geminids, yeah. In the realm of astronomy, experience takes you a long way, folks. So it's just one of those things you have to put in your time. Viewing apod.nasa.gov will help. Taking a college astronomy course might help. Understanding basic physics certainly would help. apod.nasa.gov. Today's random object's not random at all. This is the XMM Newton. It's the X-ray imagery of the core of the Milky Way galaxy, known as Sagittarius A star. The crosshairs is on the massive radio source around which all of those hot blue stars are orbiting. Again, to put it in motion, this is sort of what's going on at the core of the Milky Way galaxy. And we see similar things happening, not the same things, but similar things happening at the cores of other galaxies like M31, commonly known as Andromeda. So this is the X-ray imagery here of Sagittarius A star. Again, it's quite a busy spot in the core of the Milky Way galaxy. Let's talk about Sagittarius B. Yeah, Sagittarius B. Here it is. It is a cloud of dense molecular gas near the galactic core, and it has a couple regions there with some active-looking star, quote, star-forming, end quote, filaments. That is on the Chandra, by the way. That's the Chandra X-ray imagery. Let's take a look at it in some other wavelengths. For example, in ultraviolet, it is not a bright area at all. That's the XMM Newton ultraviolet survey. It's also dark in optical bands. Again, Sagittarius B is a highly dense and active molecular cloud very close to the galactic core. The massive radio source known as Sagittarius A star, Sagittarius B, the huge gas cloud. We'll explain why we're talking about it momentarily. And here's some infrared false color imagery here, 3 different wavelengths from the 2 mass. And you can see there is indeed an infrared signal there. Sagittarius B, a cloud of gas. It's covered today on SciTech Daily. You can find this article. And there is some more analysis of it. If you'd like to check out the article, the title is NASA's Airborne Observatory SOFIA observes star formation near the galactic center. That's from SciTech Daily. Yes, it is a plain stratosphere-based, don't worry folks, they're not spraying chemtrails. They're doing a survey in multiple wavelengths. So perhaps check out that article if you like. That's our cosmology segment for today. Once again, we integrated today's cosmology segment to the daily space weather video because, well, we don't have time at the moment to make a separate cosmology segment. Help us out by pressing like and subscribe if you enjoy the content. And it's time to continue on with additional features. Next, looking at charging hazards. We see some minor charging hazards here on the surface of satellites north of the equator moving into the Central Pacific Ocean. Here's the one-year chart of the relativistic electrons. That is essentially the lower Van Allen belt's electron density. And here is the GOES electron flux. The GOES satellites measure the electron flux from a geosynchronous orbit, and they endeavor to do so at the F ionosphere layer. You can see the cratering here of the electron flux just after the arrival of the coronal hole wind stream. And we can expect to see very low levels of electron flux here over the next couple of days, day or two, until the current high-speed coronal hole stream subsides. I would anticipate this to be a little bit lower than this. We'll have to see what happens. That's the electron forecast model by Noaa. Here's a diagram of Earth's Van Allen belts. Your GPS satellites must communicate with your handset through this inner Van Allen belt, and that's what we're looking at when we look at the total electron content forecast. The electron density from your GPS satellite down to your handset, We're seeing continued likely GPS errors over places like North America. Some chaos happening in the electron belts once again here. And we typically do see this sort of less organized electron densities happening during coronal hole wind streams. We're letting it play through a second time. Usually GPS errors happen around the equator at noon. Sometimes they get a little bit shifted due to Earth's magnetic field shifting. Electrons are only about 1/1800th the mass of a proton. Next, another diagram. This shows you where the F ionosphere layer is. It's located at about 300 kilometers of altitude. And here's your ionogram from the Bureau of Meteorology of Australia. And we're seeing high and low frequency anomalies happening here. Rather than attempt to explain those, I'll just let this play through, bring up the latest image, and show you the anomalogram. So that's the ionogram. Here's the anomalogram showing you anomaly in megahertz from the 30-day median. And you can see high frequency anomalies showing up in the Pacific Ocean. Low frequency anomalies around the equator here. Southeast Asia, Indian Ocean, Northern Africa, Northern South America for the low frequency shown in red. High frequency anomalies are shown in blue. Some major low frequency anomalies over the Northern Indian Ocean as well there. Anyway, there's the latest image. That's 12:30 Universal Time. Pardon our lateness today. There's the ionogram and there's the anomalogram. Pretty significant low frequency anomalies in the Indian Ocean at the moment. Have you been watching our meteorology segments? Well, they're just spectacular. And if you don't know how to forecast your own weather, or your own space weather for that matter, look us up. And we're going back to Cerro Tololo for the ground-based solar observatory. These are our bonus features, folks. And there are quite a bit of filaments in the northern hemisphere. You can see all these dark absorption features here. Those are all filaments that are suspended out in the solar corona. Again, we've got 3 sunspot groups. None of them are likely to produce major flares. Here's your latest intensitygram and your latest colorized magnetogram. Alpha class, and turning into a beta class. Check it out. We've got new fields. That is now a beta class sunspot, so that's a little more likely to produce flares. Here's your GOES 16 latest SUVI imagery. That's helium, by the way. That's ionized helium, 304 angstroms from the GOES 16 SUVI. And as you can see from the timestamp at the bottom, it is quite timely data indeed. Next, a close-up of some coronal holes in the southern hemisphere. What evil lurks in the heart of coronal holes? None at all, although they do send out high-speed protons and give us insight into the sun's magnetic field progression and so on. How about some composite imagery to close things out here from the SDO, the Solar Dynamics Observatory? This is ionized helium and ionized iron, 304 and 171 angstroms. Thanks again for tuning in, folks. Congratulations on realizing the channel exists, and may that solar wind be at your back. Please visit links and support links below channel by picking up merch, becoming a member of the SMASH team, and realizing that opinions expressed in the video, not necessarily the opinions of SMASH News Network, least busted, name it news.